Hello again. Today we are going to just do a quick review of exponential growth and decay and introduce the idea of a natural log and e. On this first slide, we just need to decide if it's exponential growth or decay, any initial amount, and a percent of increase or decrease. This is from last week, so it's just a quick review here. Y equals 1.2 to the x. That 1.2 tells me that it is a 20% growth. And since there is no coefficient, technically it's a 1, so our initial amount would just be 1. Question number 2, 0.78 to the x, would be a 22% decay. Question number 3, 5/8 to the x. Well, if we think about 5/8, the difference between 5/8 and a whole is 3/8. 3/8 as a decimal is 0.375. which would be 37.5% decay. Looking at question number 4, 28 times 1.03 to the x, that would be a 3% growth. That 1.03 tells me 3% growth, and my initial amount would be 28. The last one here, 25,000 times 0.95 to the x, we would have a 5% decay, and 25,000 would be our initial amount. Take a second here and read through this. Natural base e is basically a special number, kind of like pi. It's an irrational number. It has a specific value of 2.71828182846. It's irrational, so that decimal value keeps going on and on and on forever. So that we don't have to use a rounded decimal for that, we use the variable e. E comes from this right up here where you have 1 plus 1 over x to the x. Basically, as your values of x get larger and larger and larger and larger, that value gets closer and closer and closer to 2.71828182846 and so on. And so again, so that we don't have to keep rewriting that decimal value or round, we use the variable e. So on your calculator, e, just plain old e without an exponent, is second function division. So you'd hit the second function, which is your blue button, and then you'd hit the division sign, and it will give you the e. If you were going to raise that e to a power, you would want to use second function ln, which would give you the e to the x. Take a second and find that on your calculator. A log with a base of e is called a natural log. So basically, these two things that I have in red here are the exact same thing. Y equals log base e of x is a natural log. So log base e of x is equivalent to ln of x. When you find e on your calculator, you are also going to need to find the ln button on your calculator, and the ln button basically gives you down here where it has ln of 4, basically that's log base e of 4. So just practice on your calculator a couple of times, finding that ln button and calculating what that would actually equal. So the natural log of 4 would be, you hit ln 4, enter, and you should get 1.386. The natural log of 0.5 would be negative 0.693. The natural log of 1 is 0. The natural log of 3 is 1.0986. And if you notice, the natural log of 0 and the natural log of negative 8. When you go to put those in, it tells you there is some type of an error because you cannot have the natural log of 0 and you cannot have the natural log of a negative number, just like you could not take the log of those. Simplify each expression. Express your answer as a decimal to the nearest hundredth and in terms of e. In terms of e just means you're going to leave the base as e. When you do your homework over this, it'll just ask you to leave it in terms of e and not actually calculate it out using your e to the x button. So if we have e to the third times e to the sixth, our base stays the same, and we add our exponents to get e to the ninth. If we put that into our calculator, if we did second function ln, and we get e to the x, if we put e to the ninth power in there, that is 8,103.08. If we did 16e to the fifth divided by 4e to the fourth, if we simplify 16 over 4, we get 4. E to the fifth over e to the fourth is just e, or e to the first. If we calculated that out with that decimal value for e, we would get roughly 10.87. 3e to the negative 4x, that 2 on the outside has to get distributed to everything on the inside. 3 squared is 9. E to the negative 4x squared would be e, inside outside the parentheses we multiply, so it'd be e to the negative 8x. And since we don't know what x is, we can't actually put that into our calculator and get an answer. These are just a couple more examples of that. Keep the base the same, e, we add our exponents, and we get e to the 11th. Notice it says in the directions to leave your answer in terms of e. 24e to the 8th, 8e to the 5th, 24 divided by 8 is 3. E to the 8th divided by e to the 5th is e to the 3rd. The last one here, 10e to the negative 3x to the 3rd, would be 10 to the 3rd is 1,000. E negative 3x times 3 is negative 9x. When we are talking about exponential growth and decay with a natural base e, you'll notice that exponential growth and exponential decay look very similar to the graphs of what we looked at before. Down below in red, it shows what each of the variables is. A is the coefficient or the starting value. E is just your natural base e, and r is the rate of growth as decay. When we are looking at these natural base functions, e is our base, and to decide if it is exponential growth or decay, we look at the value of the exponent. If it is positive, so if the exponent is positive, it means it is exponential growth. And if the exponent is negative, it means that it is exponential, or it means that it is decay. So what it's asking here is tell whether the function is exponential growth or exponential decay, and then graph it. You will have access to Desmos or a graphing calculator, so you can always use that to graph it. Y equals 3e to the x. Your exponent is positive, which means that is going to be a growth function. And this one, negative 5 or negative 0.5x is negative, which means that would be a decay. Just a couple more here. Again, we're just looking at the value of the exponent. That's positive, so we would have growth. Next one is raised to a negative power, so that would be decay. And again, probably shouldn't have a negative there. Positive exponent, which would be growth. One of the ways that you can use the natural base e is when you are compounding interest continuously. This is a little bit different than what we did before when we compounded interest daily, monthly, quarterly, weekly, things like that. So we have a formula where the amount you end up with is the P, which is the principal amount you initially invested, E is your natural base E, R is your rate as a decimal, and T is your time in years. So for example, if you deposit $4,250 in an account that earns 5% annual interest continuously, and they want to know the balance after 10 years. You'd have 4,250 E to the R times T. Well, your rate as a decimal would be 0.05, and your time would be 10. When you put that into your calculator, you end up with $7,007.07. Okay, just a couple different ways to look at these natural-based functions. This is an example of comparing money that I invested with money that a friend invested. It says you and your friend each have accounts that earn annual interest compounded continuously. The balance A in dollars of your account after T years is A equals 4,500 E to the 0.04 T. So my account is modeled with an equation. Okay, my friend's account is modeled with the graph. So anytime I'm answering questions about my account, I'm going to look at that formula. Anytime I'm answering questions about my friend's account, I'm going to look at the graph. So it asks, what was my initial investment? Well, my initial investment is that coefficient, which was $4,500. Interest rate, if you look at the exponent, e to the 0.04 t, my interest rate was a 4% interest rate. When it's talking about my friend's initial deposit, that means I'm looking over here at the graph, and it looks like she had an initial deposit at time is 0 of $4,000. So she invested less than me, so she invested $4,000. Then it asks, what is the value of my account after 10 years when t equals 10? So in our calculator, we need to calculate that out. So I initially invested $4,500 e to the 0.04 t, which is 10. And when we put that into our calculator, we end up at $6,713.21. So after 10 years, my $4,500 is now worth $6,713.21. What is the approximate value of my friend's account after 10 years? Well, if you look at the graph, after 10 years, at t equals 10, if we go up, roughly, we're going to have to do estimating, a little bit of estimating since we are using the graph. So it looks like it's just over $7,000, so we could say it's approximately $7,100. So she initially invested less, I invested more, but she ends up with more. That's mostly because she had a higher interest rate. So again, if your friend initially invested less than you, why is her account worth more after 10 years? Because she had a higher interest rate. And we will talk about how to figure out what that interest rate is a little bit later, but not today. So have a great day.